All right, up next we have a really awesome treat. So we have a panel on token engineering moderated by Ryan Selkis, the founder of Masari. So token engineering is this brand new emerging field like many of the things that we all do. If it sounds new, that's totally cool. I'm just getting up to speed as well. But literally, the folks you're going to meet right now are the people who are like giving birth to this field. So yeah, take it away, Ryan.
You guys are going to be so unhappy that you left this session. All right. You guys good? Comfy?
Yes.
Yes.
All right,
Yes.
Who's still alive out there? It's 4 o'clock, end of a long day, jet lag, ether is dead, right?
Either.
Haven't checked.
Have you guys like started building your solutions, like porting it into the Bitcoin blockchain yet, or?
We built on that 5 years ago.
Okay,
Yeah, I think that's old story.
that's the OG right there. Okay, cool. So appreciate everybody if they could either join us for what's going to be a really awesome discussion, or take the conversation outside just so people in the back can hear. I'm Ryan Selkis, the founder of Masari. I'm super excited to be moderating this panel, not just because we've got 3 really smart gentlemen next to me that I think are really at the cutting edge of this kind of emerging field, but because we tend to put really glossy, fancy names on things in crypto. But I like to think about token engineering much more simply. Like, we're designing provably fair games from scratch. And incentive systems from scratch that ultimately should replace companies and organizations that are traditionally centralized. And it's really hard to design games and have games that are actually like fair and fun to play, and can actually reward actual value creation and make sure that the winners of the game are the best incentivized and most honest acting actors. So that's how I like to think about token engineering. But this is such an early term, just like everything else. Like, let's just start with the basics of like taxonomy. Like, how do you guys define what this emerging field is, and what you're doing on a day-to-day basis when you're like engineering these token incentive schemes?
Everyone's looking at me. Hi. I'm Trent, by the way, co-founder of Ocean and BigChainDB. And so I'm trained as an electrical engineer. And in engineering, there's all these engineering disciplines, right? Electrical engineering, mechanical, software. And engineering is a few things at once. It's a collection of, I like to say, theory, practice, tools, and responsibility, right? So theory derived from physics, et cetera, Newton's laws, Kirchhoff's voltage laws, all of these things. Practice as in the heuristics that you have, the procedures, the methodologies you have to build these things. The tools to do them, software and otherwise, and then the responsibility that whatever artifact it is that you build, you take the responsibility for building it. And engineering is really about developing artifacts and maintaining those over time, whether these artifacts are circuits or mechanical devices or tokenized networks, public utility networks. So it's really all those things together, this collection of things. And it's not just about ethics, it's not just about one thing or the other, it's this collection of ideas. And the dream is that it emerges as its own, honest-to-God engineering discipline, side by side with mechanical engineering, software engineering, et cetera. We saw that, probably the last major engineering field that emerged was software engineering in the late 90s. Now we have this new one emerging. And it's kind of amazing, right? In electrical engineering, it's driving this $300 billion semiconductor industry. And at the heart of it, there is a subset, that's $6 billion industry for circuit design. We are already at a $250 billion industry, or maybe with a drop of ether, it's 200 billion, who knows. But overall, an industry that is already the size of the whole chip industry, that's been around for like 50 plus years, 70 years, right? Yet at the same time, we have hardly any of the tools. We are like 1970 for the tools. Not even 1972, not even 1980. We are literally 50 years behind. So there's this huge gap between the value of the ecosystem and the dynamics being designed and the ways that we can actually address and design these problems. So we're all flying by the seat of our pants, and in some ways, if you're not scared, you should be.
The
Always
game got dark.
Yeah, I was going to say, always a good way to open. Hi, so I'm Ben. A year ago, we co-founded Open Simple Token, and it was in a similar vein. So we were working on Ethereum. It got a lot of popularity, but as Trent said, it started to take the shape of tokens. We have this programmable blockchain, but really what it's being used for is defining tokens. And we have this new tool now. We have this tool to define new provable fair games, provably fair games. But it's very early days. And if we want to build a world that we want to see in the future, we need to do it together. And so that's really where Open Simple Token, OpenST, came from, is bridging that gap between where Ethereum is today and enabling thousands of more developers to experiment with building token incentive models for their own application. And that's what we've been doing the past year. In many ways, we look at ourselves as sort of tool providers to give this, and I think Trent will relate to this, evolutionary platform, where if we can build thousands and thousands of these rules, we can see which ones works, which ones don't. We also have to simulate them before we put them into practice, because like an engineering discipline, we need to do safety testing. We're playing with people's money, potentially with dire consequences. So we need to mature this field as rapidly as we can, and that's also what we're trying to do with OpenST.
Hi, Dimitri. With Trent, I'm doing more research and product at Ocean. I guess half of the room wants to build Skynet. The other half of the room wants to build something like the collaborative crypto commons. And we want to build it fast and now. So we need to have the tools to do so. And as Trent explained, we're kind of backlagging there. Personally, I think I come from a dynamical systems theory background, and there you try to comprehend very big systems and manipulate them. So you have like top-down design, bottom-up verification of that design, and I see so many gaps in each of them we still don't have. For example, just clear functional analysis, drilling down into component level, verifying those components, those libraries, and then modeling them back up, having simulators, and then do functional verification on top. So we're missing a lot of these things in the stack, and we're in a socio-economical system, which has a lot of externalities, a lot of behavioralism, so a lot of unknowns. So the things we do now is like long shots, put it directly into the hands of devs and clumsy users, and then put a lot of money behind it. And yeah, I mean.
So the first half of your answer, you kind of talked about the theoretical, and then the second half, kind of a consistent theme with what Ben and Trent had started with. It strikes me that the first thing that you have to think about when you're engineering these systems is the externality that's completely outside of anyone's control, and that's the price, right? Because while you might want to put these in a sandbox, test them, find a user that's actually going to use the token as designed, everybody's speculating with these things. So right from the get-go, people are playing a different game, right? Even if you have the best intentions when you're engineering these systems. So part of it is safety, but how much of what you're doing or what other engineers should be thinking of is really just putting intentional brakes and like circuit breakers on these systems so that you can actually give them a chance to thrive in the wild?
Yeah, I mean, I guess one of the first things to do is like look at all the primitives that are available and testing them out at the lowest level. So the micro games or the simple things, stake slash, zero sum, creation, TCR, all these type of things. So if we already kind of know how these behave, I guess that gives you more of a controlled environment. Not a circuit breaker yet, but at least a circuit analyzer.
I think you're entirely right to say that this is speculative still, this entire multi-billion-dollar game we're playing or experiment we're hosting. And I think the most important driver to control that that externality of the volatility of the price is to onboard users. But then you have a chicken and egg problem because you can't put them on an experimental system. And so we do need to have those circuit breakers, as you said, or control systems, because otherwise who goes first, right? And in the most important game that we are building ourselves is the scaling solution as well. There we deliberately design it that a validator pool will warm up for a year, but then the circuit breaks go off and it's on its own, but you at least have that 1 year where you can assert that it's playing a steady game and try to break that chicken and egg cycle. But then it's custom to every game you're designing, so at least for us for now, I haven't seen a general way of
Well, and you bring up the other point, right, because these are experimental systems, so if you did want to get them in the hands of users, one of the other major issues, particularly since these aren't just licenses, but they're tied to tokens that have economic value, is just the difficulty in iteration, right? So you get one piece of the token design and the token engineering wrong, one piece of the incentive schema wrong, and you have a hard fork situation. You have to, have this cabal of engineers to meet to talk about how you, change the money supply, right? And then, everybody, it's very easy to critique that because it looks a lot like the old guard of the old world. How do you guys think about balancing and communicating with your broader teams and then communities, like how to go from centralized, experimental to fully decentralized, and what are, maybe it's bespoke to each project, but are there certain kind of critical phases that each of these token projects should go through when you're going from guy with an idea, team with an idea and execution to global decentralized network?
I think right now, actually, people will give answers here and there for that, but we're maybe at 5% of the possible answers. Very, very little of this has been explored to any level. And at the end of the day, basically, you are developing a dynamical system, right? So where you have, say, like, if there's 3 dimensions to the state, X, Y, Z, then you have this thing that's moving around in this state space, right? Following this trajectory, and that's the state of the blockchain, right? And it's not just 3 dimensions, it's, thousands of dimensions that it's following through. And then the question is, how can you set it up such that as it's going through this trajectory, it just doesn't fall off and completely break, right? And that is the question, like just observing the trajectory once, that would be like simulation of the blockchain design, right? Or even putting it out there in a sort of a testnet nominal way. But if you actually want to design for it to be robust, then you actually have to account for worst case behavior, or perhaps probabilistic behavior, one of many possible paths according to various possible behaviors that humans have, right? And so there are, back to the sort of circuit land, there are circuit simulators to simulate dynamics, and there are also tools to verify in a worst case sense or in a probabilistic sense. And it's pretty straightforward in circuit land because it's a closed system. It's straightforward, right? The problem is in blockchain land we have pesky humans. So how do you account for that? One of them is you can actually try to model all the possible ways that the actors can interact with the system and account for that in a worst case way, but that very quickly becomes too pessimistic. If you could try to account in a probabilistic way, maybe that's going to be less pessimistic, but there's, if you have the wrong probabilities, then things can fall off the rails. So overall, to try to understand the range of possible things right now, we do have to resort to sort of human simulation, sitting around over beers, trying to break each other's designs, or playing card games, and different teams are developing card games for their token designs and so on. And then also leveraging the economics themselves, right? So, I think an example of a failure is one day before mainnet launch of your $1 billion network, you have a $10,000 bounty. I won't name names, right? That's a fail. Better than that is, maybe you have growing higher bounties before you go to mainnet launch, or maybe you just launch mainnet right away and it's on some sort of market maker that as people realize that it's growing in value, then it's just there. So there's a bunch of things, or circuit breakers and so on, to sort of have these warm starts rather than going from 0 to production, right? And all of these are basically helping to adjust the system over time such that it ends up robust. But this is, make no mistake, this is a question of robust design of a dynamical system.
Yes, maybe we won't get negative, right, in terms of who's clearly failing, because I think, in my eyes, that's kind of the default. No offense, but that's just kind of the way of the world right now. But yeah, I find that these conversations, especially because you guys know I'm not an engineer, so I just do my best to keep up. But what I typically find is these conversations get very abstract very quickly because we are so early. I'd be curious to hear, outside of you distinguished gentlemen, like what are some projects that have nailed some part of the token engineering stack, aside from Bitcoin, right? I think that one's kind of tried and true. But aside from, maybe that's a debate. I thought that just everybody in this room agreed that Satoshi was a genius, and that was a pretty darn good incentive design scheme. And it's all right. We can challenge like around the periphery, but I guess my point is something that's newer, right? When the stakes have been higher, when the environment is this awash in capital, right? Who's done a good job of navigating the difference between the speculative furor, right, and the actual system architecture in the last year or so, right, going from 0 to 1?
I don't know. I'm thinking Numerai kind of have an interesting feedback loop. Maybe there's a few others like AdChain kind of.
But let's roll into the specifics. Like what made that like
the simplicity
in your eyes a successful iterative process?
I wasn't in the design process of it. I think Trent was more involved in like reviewing the papers and stuff like that. But what I gather is that it's a simple protocol, that easy to grasp. It doesn't have too much externalities. It has the price setting inside of the system. It has a bit of a prediction aspect to it, which can be modeled by stochastics and other stuff. So yeah, I think every project that has a very simple, clear incentive would be on top of my personal list of curated incentives. Yeah.
Do you think that projects need to start with a narrow use case? Because there's a lot of platforms that are getting built now, right? Everybody's building a marketplace, a platform,
I think they should.
An Ethereum killer.
Initially, for token engineering, it starts off with defining clear objective function. Like, where do you see your network evolving towards? What's that dot on the horizon? If you create a self-sustaining or anti-fragile network, where does it evolve towards? And then you're gonna try to make a control loop in order to basically gradually converge towards that objective function. And that's just the most difficult thing to do, is like figure out a concise, precise objective function, which also makes you think about what's the actual utility that you are putting in your network.
Ben, same question, yeah.
Yeah, so it's hard to name a specific project, but I do feel that there's 2 points towards sort of a guideline that I would want to make. First of all, I like that you mentioned that Bitcoin or Ethereum themselves are also games, right? So there's not a clear distinction between a token engineering as an application and the platform that you're building, because both of them are games. And so I think a very first lesson that I myself learned and I respect learned from other projects, specifically actually Tendermint, to give credit to where credit is due, is try to build with the group philosophy. Try to build modular components that serve one function and that can be helpful for other projects, so that you're not trying to build the whole world in one piece. And then that comes down to your normal development cycle as well, because on the one hand, we've all, over the past 20 years, adopted agile development, but then you cannot add a smart contract layer, you have to launch it. And so the sort of, as a development philosophy, I think if you think about modular pieces that serve one function, then you start out as agile as possible, and you try to identify the most important foundational components first, and you try to shrink them and shrink them and shrink them until they're one singular purpose, and you've battle tested them. And so Ethereum, for example, has been established. ERC20 tokens on Ethereum have been sensibly established with some lapses here and there. And then you push that project forward, because also what Trent said, we're only scratching the surface, right? 2 gravitational particles are calculable. A third one produces a chaotic system. As you have more of these small components interacting, you have a space you cannot imagine. So you need to build it gradually. And I would argue the points where you don't have a good control over it, keep agile development. Keep them somewhat centralized. Produce a spectrum of gradually decentralizing some of the functionality and make it a multi-year project, because it will take time.
Yeah, I think like several of the points you touched on, a really great example is the aerospace industry, right? It's very, very bottom up, because there's very high, it's very expensive to deploy something, and there's very big pain if it fails, right? You don't want a jumbo jet falling out of the sky. So when you're designing a new jumbo jet, you're generally trying to reuse existing well-known building blocks and compose them in these hierarchical ways that are generally well-known, right? And you make tweaks here and there and here and there. So if you look at the blockchain projects, right, sort of pre-Ethereum days or MadeSafe, there was all these clones of Bitcoin, right? And they were just tiny deltas, right? Litecoin took Bitcoin and changed a couple things, and most of the projects were like that. And Bitcoin was a known design that was working, right? It actually took a bunch of new leaps and ideas from other projects even before, but it was the first time that it really worked in this new way. But once it was demonstrated to be working, then small tweaks here and there, you kind of have a good feel because you're not making any major leaps, right? And even in Ethereum design, at the heart of it, it's also proof of work. And they did a lot of amazing things with gas and all this, but they tried to keep it on as minimal delta of changes in terms of the token dynamics, and that helped a lot. And as we have these new building blocks, it's hard to combine more than one component and have success, right? So we don't have that many nice examples to point to yet. But I really love like the people that are deploying TCRs where they make sense. I love the restraint that they've had in having just a TCR like add chain and spank chain and so on. I think that's really great, actually. So some of you here in the room, good job, guys, really. So beyond that too, there's other designs that have worked that are kind of amazing, right? Like FOMO 3D, it was kind of an experimental cool thing that just like, wow, right? But to us, like in the world of thinking about token dynamics, it's amazing. So these building blocks that are emerging, they're shown to be working here and there, and now we can start thinking about how to combine them. And because we don't have simulators yet or anything, it's like designing airplanes in 1912, right? As opposed to in even 2012. But in 2012, we still don't have great airplane simulators, right? So that's why we keep going bottom up with that.
So you mentioned Bitcoin, spank chain. So basically, it's still like drugs, porn, and Ponzi's with FOMO 3D. Like those are still the killer apps, like true design. It's not too far off the mark, and
don't forget ads, internet ads,
and internet ads, right? Like
the driver is Facebook and data silos.
We should all just retire, like we've won, right? So you mentioned and this kind of goes to Ben's point too, but you bring up the aerospace industry. You don't normally want your 747 to fork mid-flight. Bad for business, and that's How do you even start to think about designing for that externality? Because it happens all the time, and I have a feeling that it's going to get much more pervasive, even for really successful projects and strong communities with things like Cosmos and other interoperability solutions, right? So how do you maintain the security of any single application or think about the connective tissue of these different blockchain projects and how value might ebb and flow and ultimately even screw with the security of your underlying system? Like how do you get customers comfortable with that, enterprises comfortable with that dynamic?
I think we can partly orthogonalize security from basically fucked up token dynamics, thanks to the likes of things like Polkadot and Cosmos and so on, right? So where you can actually have recourse, or even Plasma, right? Where you have recourse. So then it's basically you have to just handle good token dynamics, and then it helps because you can just orthogonalize these two problems and then really focus on trying to have good token dynamics. I'll stop there. I'll leave it to the rest of you guys.
I guess if you want to build a bridge, a mechanical bridge, and then you're looking at the eigenfrequencies, and that gives you a measure for stability of the system. You want to have them damped. You don't want to have them like being oscillating or going exponential. So extracting like performance measures from these systems, like denoting how stable they are towards externality fluctuations, that would be one way forward, or predicting like which system is getting vulnerable towards more fluctuations in the market. So having this...
Do you like staking and burning mechanisms that have been introduced? Do you think that adequately covers some of the security challenges for some of these subnetworks?
If that improves the feedback loop and dampens or basically adds more resistance towards fluctuating externalities, like really thinking about systems, how they would evolve, then yes, if it helps in robustness, definitely. But I think you can extract performance features from an existing system to see how stable, anti-fragile, or self-sustaining it is.
I'm still on FOMO 3D because it's an absolutely brilliant story. But relating to the question, and like if you think that writing a Ponzi scheme shouldn't be that hard of a token engineering problem, but even that was hacked, right? I mean, and it was hacked in a genius way by manipulating the underlying Ethereum chain. So it goes to show that we definitely need to build hierarchical systems, as Trent said, so that you can have recourse on them. But we should also have modest expectations. You can't build, I mean, the Airbus 380 today. You need to have a spectrum where you start out with recourse systems on the most trusted system, let's say Ethereum proof of work, and then do a very simple use case within a bigger context, because you'll get it wrong initially. So
I think there's one other thing too, like, you know, depending on who you ask, forks are a good thing or forks are a bad thing, right? And I think in this context here, forks are a wonderful thing because you can actually explore many design variants very, very quickly, and then the fork that does well, add something new, etc., can really survive, and it's, you know, sort of a new variant of a design pattern that's clearly working, right? The other thing about, you know, difference between jumbo jets and software, of course, is that software is malleable, right? You can change it. That said, blockchain software, smart contract software, all this is actually not quite as malleable as the software of the last 50 years, right? So we have a bit of a delta there. We can hard fork towards, you know, new changes and stuff, so things won't fall out of the sky, but it's not quite as malleable as it was. And one other thing in terms of the forks, right? Sometimes they're for better. So just, you know, next to the porn and next to the ads and stuff, we have Dogecoin, right? So you know, free prize inside. So some of these are showing new value in new ways that we didn't expect.
And actually, so we've been very cautious on, like, let's try to not rush too far ahead, and be reasonable about our time expectations. At the same time, it took a couple of years for Bitcoin to become trusted. Then Ethereum came relatively fast after Bitcoin. But now you have this foundational layer, and you can start experimenting in parallel, and we are doing it in the masses. And so a large part, I think, is, can we provide the good research, the simulators, the tools to have as many as people as possible in a sensible, constructive way collaborate and experiment in parallel.
So here I see a bit of a problem. Massive parallel deployment of all these games, and then you basically sharding your user base. So you don't have enough data points, or so. If you really put enough money behind the game, then I think it might be worth people playing it, or just make it weird enough.
There's a lot of people in the plan.
So, you know, obviously ETH Berlin, the centerpiece of this event is the hackathon. So, you know, by definition, we're going to have a lot of teams that are just going from 0 to 1 with very simple applications over a short period of time. You guys read a lot of white papers, help a lot of teams just think about hacks. When you're thinking about very rudimentary systems designs, what are some of the things that you caution teams to avoid or kind of recommend as, like, either must-have tooling or design choices, or I don't know, someone you know, some college graduate is here putting together a team this week. Like, what's, if you give him like a 30-second pep talk on how to win this hackathon, like what's going to prevent him from imploding and, like, or her from imploding and falling on her face?
Tell him to go back to school. Nothing to look here. No, I guess, like, yeah, just start with very, like, simplicity is key in all of these things, and just see if you can, if you're willing to eat your own dog food. Like, we always try to play the game ourselves. If we don't like the game, then probably nobody else would like the game as well. So if they can't have a beer night playing the game with themselves, or it's too complicated for them to explain, then better move on to something else.
I would say try to keep it simple, reiterating the same point, but also try to find that one function that currently is missing. Try to, because you want to capture that collaborative nature of the space that's uniquely to blockchain space. We can collaborate and both benefit. So you have a lot less competition and far more emphasis on collaboration. And so use it to your advantage. Build modular components and build in collaboration with as many as people. Get feedback, talk to them. It's often overwhelming, but it's worth it.
Yeah, kind of related, right? token dynamics is only one of the places of possible innovation in the DApp or the blockchain you're trying to build, right? So if you can actually, it's quite often tempting to try to innovate across the board everywhere, but that's actually a bad idea. You know, if you're an entrepreneur, you should actually be as uninnovative as possible across the board, except for those one or two places where you really chosen your battle. Same thing here, right? Reuse, 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 and then pick that one thing where you're doing something novel, and then pour all the gasoline on those flames, right? And everything else reuse.
Kind of perfect marriage of the first two answers. Use what you can, keep it simple on the innovation, right? How are we doing on time? Got about 5 minutes left? I want to make sure we don't go over because I knew we were going a little over.
I think less. 5 minutes. Time was 10 minutes ago, so.
I didn't see. I took my glasses off, so.
I see somebody saying that it's not happening anymore. We're finished.
Are we done?
We're done.
All right. Lightning round. No.
Question from audience? One?
Yeah. If there's one magical question from the audience, maybe we can do that. But otherwise, we're going to get back on schedule. Covered everything. Great job, guys. Congrats to the team.